I think this is session 4, yeah, session 4, day 2. Okay, so we have how many participants in this room? 2, 3, 4, 5, 6, 7, 8 participants in this room. Okay. Each participant will be presentation about 10 minutes and then 5 minutes for presentation for question and answer. Okay, let me start to the first presenter. I would like to call the first presenter. This one. Okay. The paper ID 1834 with the title Improving Electrical Energy Yield from what is photovoltaic system under partial shading. Okay, so Mr. Nur Hidayat, yeah, you can start your presentation. Can you share screen with us? Okay. Sorry, I cannot hear your voice. Please check again. No, your voice.
Hello, my voice.
Yes, but it's very.
Hello.
Yes. Can you speak louder?
Okay, is louder now?
Yeah. You can start now.
Okay. Thank you. Let me introduce myself. My name is Nurjaya Tarif from the Department of Electrical Engineering at Diponegoro University, Semarang. I will present about my paper. This is improving electrical energy yield from photovoltaic system under partial setting. The background of problem in my paper is photovoltaic PV system has lower efficiency of energy conversion. PV system output power fluctuates based on instability of weather condition, unstable environment, and weather change. Solar irradiance can change suddenly before solar irradiance fall on the PV array because it's blocked by object. This factor causes an instantaneous change in the peak power point and a multi-peak condition due to partial set condition. And the solution from this problem is using MPPT, maximum power point tracking, to control and optimize the converted solar energy to electricity at maximum rate. This MPPT used improving effort of to harvest electrical energy taken from PV system under partial setting condition by combining two algorithm. In this research, I used two algorithm combined by a simplified Paralel algorithm for maximum power point tracking and using PNL algorithm for faster convergence. This is the illustration about partial shading. Partial shading condition is a condition when a part of PV surface blocked up by an object. In the picture is the sample a picture of partial shading condition when the PV blocked by some object like a tree or moving cloud. What is the effect of partial shading? The effect of partial shading is the presence of multiple power peak. In this illustration, there are two configurations of our voltaic system. In the left side is the normal condition, and the side is the partial set condition when the every solar cell have a different radiance. And this is a PV curve on the photovoltaic. When the partial set condition make in the partitioning, it have a 4 local peak curve. This make the problem when we try to search the maximum power peak. This is the basic of Paralel algorithm, and the basic is the less pressure Paralel will move to the breakthrough firefly. The breakthrough firefly will move randomly or remain still depend on program. Environment on condition of fairly behavior. This is the formulation for the basic firefly algorithm. In this, the animation to destroy the firefly itself. This is the initial position. When approaching movement, there is the equation in the green circle, and there are the movement in this side. And then the position in the right side is this. And the simplified firefly algorithm is a simplified from basic firefly algorithm itself. There is only one variable parameter, that is the cycle. We use the cycle in boost converter to control the maximum power itself. And rank from 0 to 1 is very narrow. So it's not necessary to use gamma and alpha coefficient. Only beta convention used. So the equation become more simple. From this equation, it's more simple, like the final equation like this. It's more simple and more simple and more easy to use. In this paper, I used to combination algorithm from simplified firefly algorithm and PNO. PNO is a conventional method algorithm to set the maximum power in solar cell. The pro is fast tracking but less accurate and usually trapped on the local power peak. And the firefly more accurate but slow tracking. Is combined the two algorithm. We use the best firefly for accuracy and PNO for fast tracking. This is the animation for to illustrate who the firefly can use in this paper. In every simplified algorithm for fatal setting condition. Edge firefly is separate edge under. It represents maximum power peak, and then when the base power, the less power will try to go the maximum power until it's look until it's convergence. But when it less convergence, it switch to perturb and observe algorithm for faster tracking. And we got the power maximum in this paper. I use PSIM simulation for MD4 system. This is have for solar cell in connected series, and we use the control by use boost converter to step up the voltage, and the MIPD using direct duty cycle to control the boost converter itself. And this is the result of my research. In every condition, a setting pattern we use for setting pattern, and the maximum power efficiency is up to 98.85%. And then it is the last result of my paper, and the conclusion is simulation results show the satisfactory performance for escaping multi-peak condition and high accuracy in tracking global maximum power peak under fatal setting condition. Simulation results also show that the hybrid and PNO algorithm in MPD still can detect successfully under dynamic shading pattern change and can realize the process on PPD controller. The efficiency of tracking global maximum power peak is alpha scales are higher than 98.75%. Thank you.
Thank you for your presentation. So, any question for the audience? For the audience, you can write your question in the chat box, or you can raise your hand, or you can talk directly to the presenter. Okay, any question? So if there is no question, I have one question for you. So is this improving the efficiencies? I checked.
Yeah. Improving
Okay,
efficiency.
improving electrical energy yield. Okay,
Yeah.
so the improvement is about 98%.
Yeah, 98%.
98. Any specific condition that your research can be applied? Maybe I think several research cannot apply in some situation. Maybe you have some situation that this improvement cannot achieve. What this situation? Can you tell me about this?
When there is many connected solar cell in series connected configuration, it's different metal setting. So the solution is we try to setting the parameter of the control itself to detect the setting condition. That is the problem.
Like the weather is not in any contribution about the weather, maybe the rain weather or something like that is not contribute to your research. No.
No, it's only the solar radiance for my research. For the temperature itself, it can be developed for another project. It's only
Okay.
condition when the metal setting condition.
Okay. Okay. Thank you very much for Mr. Nur Hidayat Arif. Okay.
Thank you.
Thank you very much. Please give applause to Mr. Nur Hidayat Arif. Thank you.
Thank you.
And you can turn off your share screen. Okay. Okay, thank you. Okay, now we move to the next presenter. The next presenter with paper ID 1X69. 1X69, okay. This is, we have Mr. Rizky Nur, Mr. Rizky, okay.
Yes,
Okay, so you can start share your PowerPoint with us. Don't forget you have time about 10 minutes and 5 minutes for question and answer. Time is yours.
okay. Thank you, the moderator and all participants. I'm Rizky Nurias Ahmad. I'll present our research about electrical generation from waste energy running water of household plumbing. The content of this presentation consists of introduction, fundamental theory that consists of small-scale electric power system, pico-hydro, PMDC generator, and boost converter. And then design and simulation, results and analysis, and conclusion. The introduction, the potential for utilizing water energy as an energy source to generate electrical energy through power generating units is quite large, which is around 75,000 megawatt, while 10% of the total potential, which is 7,500 megawatt, can be used for micro-hydro power plants. Micro-hydro power plants can be a solution for electricity supply in certain areas with water energy sources that are not too large. Based on the research on electrical generation from waste energy in running water of household plumbing, recommended the use of multiple converters to have a higher system efficiency. Several converters connected singly or in series or cascade have potential to solve the efficiency of the boost converter as it is operated at high duty cycle. An electric power system. Currently, small-scale electric power systems are being developed that utilize energy sources around the house, or we can call it energy harvesting surrounding house. The sources can be from hydropower, wind power, photovoltaic, and other sources. The generator connected to DC-DC converter and then can be used in DC house or stored in battery. And then pico hydro power plant. Basically, a pico hydro power plant is the smallest version of a hydroelectric plant. Because the power generated from this type of generator is quite small, one of the suitable loads for this generator is the home lighting system using LED lamps. This equipment is also possible to be in hybrid with grid and battery storage. Because scale hydropower has a lower scale for generation under 5 kilowatt. In permanent magnet DC generator. Permanent magnet DC generator is a type of DC generator where the magnetic field generated is derived from the permanent magnet in the starter. This is the equation of the DC generator. And in figure 2, we can see the generator that we used in this research. This generator is fed to a half-inch pipe, and the output voltage 12 volt, and the power output is 10 watt. Then boost converter. Boost converter is a converter that is used to convert the level of DC voltage into higher voltage level. And this is the equation of the boost converter. And in figure 3, we can see the conventional boost converter topology. This consists of sources, inductor, MOSFET, a switch, diode.
Hello? 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 Mr. Rizky, maybe a bad signal. Hello? Okay, we wait until 5 minutes.
I'm sorry, I have a connection problem. May I continue my presentation?
Yes, no problem. Yes, you can continue. Okay, please continue your presentation.
And in figure 4a, this is a system with single converter configuration. And in figure 4b, we can see the system with series converter configuration. And in table 1, we can see the generator parameters, and table 2, the converter parameters. Then results and analysis. The characteristics of generator are investigated under no load and loaded condition as shown in figure 5. We can see in figure 5a, the generators in no load condition. We get the output voltage here about 12 volt. And in loaded condition with resistor 60 ohm in 0.25 liter per second, we get the voltage drop to about 8 volt. And for comparison purpose, the model of generator is simulated by using power simulator. We can see in figure 6a, the simulation of generator in no load condition. We get output voltage 12 volt. And in figure 6b, when in loaded condition, the voltage dropped to about 10 volt. Then in single converter configuration, system runs with single converter, resulting efficiency trend to be lower at higher voltage multiplication. And in figure 7b, we can see the voltage determined at 14 volt, but it decreased in lower rotor speed as the prime mover power isn't high enough. Then we simulate in a series or cascade converter configuration. The system gives random efficiency, and the output voltage are similar to the single converter configuration.
Okay, I think it's enough. Maybe this the signal is very bad. Okay, the connection is very bad. So we can move to the next presenter. The ID paper 1871. 1871. 1871. Any in this room?
The connection is
Yes, you
probably
want to
IRS.
continue or you just
Yes,
give
Madam,
one
I will
conclusion? Okay.
Well, the conclusion,
Yeah. Maybe you can, yes, conclusion.
based on the result of the experiment, it's possible to utilize water energy in running water of household plumbing in the form of electrical energy. The output voltage of the generator can be raised up to voltage level that fits to battery terminal voltage, 14 volt. And for further development, the system requires advanced control system to manage the system to operate at singly or in series configuration to maintain higher efficiency. Enough for me. Thank you.
Okay, thank you. Any question from the audience? Okay, any question? No, okay, I have one question for you. Okay, this is electrical generation from waste. Okay, from waste.
Yes.
Any this is all the waste, or you have specific waste to be to convert become the energy, or any waste, anything waste you can convert to the energy, or specific waste? Can you tell us? Hello.
Okay.
Yeah.
We specified our research in pipe with a diameter a half inch. This is pipe that we can find in our house. So we call it from waste energy because when we wash our hand, when we
Okay.
anything in house, the water just flow. So we
you.
use the flow of the water to generate electricity. So we call it from
Oh.
waste energy.
So, okay, so this is from the water. After we use the water, and the water becomes something to like the material for generate the electricity.
Yes.
Okay. Thank you very much, Mr. Rizky Nurias Ahmad. Success
Okay,
for
thank
you.
you.
Okay. Now
Thank
we
you.
move to the next presenter. The next presenter with paper ID 1871 with the title Utilization of Water High Seat. Sorry if I'm wrong in the spell the name. As prequat using pyrolysis method.
Excuse me, Prof.
Yes.
Maybe you continue in the presentation because Miss Agatha Cindy and team is not there.
Okay.
Until Mr. Suhartono, because Mr. Anang Setio Pramudianto also is not there. Thank you, Prof.
So we move to the number 1888 techno-economic. Any person in this room?
Yes.
No?
Yes, Prof.
Okay. So we move to the what is 1, 2, 3, 4 presenter.
Yes. And
Okay. With the title is techno-economic analysis with treatment using
No.
okay, no. So 1919,
Yes,
okay,
Prof.
with title for pyrolysis of styrofoam plastic waste using Mount Krakatau volcanic ash as a catalyst.
Yes, Prof.
Okay.
Thank you, Prof.
Yes.
Okay, so
Thank you.
Mr. Suhartono, you can
Yes,
start your presentation.
Yes. Prof. Ari, please allow me to share my screen in
Okay,
recording according to the committee suggests us to make the video. Right?
okay, you can start your video. Okay.
Can see the screens?
Yes.
Okay. Thank you to moderator who has given me the opportunity to present a part of our research entitled Paralysis of Styrofoam plastic waste using Mount Krakatau volcanic ash. And also thank to all conference participants for keeping joining this presentation until now. This research is motivated by the lot of styrofoam plastic waste in our city, and some of this styrofoam plastic waste is not mechanically recycled due to economic considerations on the selling price of the products and the complexity of the processing. So the styrofoam plastic waste can be converted into liquid fuel through pyrolysis. And pyrolysis is one of the most suitable thermal conversion technology than gasification and combustion. The pyrolysis of styrofoam plastic waste can be carried out at a relatively low temperature, under 400 degrees centigrade, which is known as slow pyrolysis or conventional pyrolysis. It means low temperature pyrolysis is a feasible and promising technique to convert solid styrofoam plastic waste into liquid fuel and make harmful waste to the environmental by reducing it. Another side, volcanic ash contain quite high silica and aluminum components in form of commercial catalyst. So this ash can also be considered as a catalyst in pyrolysis as a substitute for commercial catalyst. So that the styrofoam plastic pyrolysis process can only be carried out and effective since the catalyst costs are cheap and practically zero. The small-scale pyrolysis apparatus include the main part of pyrolysis reactor, catalytic reforming for second stage degradation of condensing system, and heating system. An amount of styrofoam plastic waste in each of these experiments using active and inactive of performance catalyst to produce pyrolysis liquid fuel. Using volcanic ash as a catalyst is effective to increase the quality and the quantity of pyrolysis liquid fuel as the main product of this pyrolysis. The physical and combustion property of pyrolysis liquid fuel produced from styrofoam plastic waste was characterized on a par with commercial kerosene. The result of pyrolysis liquid fuel produced is listed on the table. It is shown that the use of active catalysts produce more pyrolysis liquid fuel than the pyrolysis process without the catalyst and with inactive catalyst. So this is the table also summarizes that the using activated as catalyst provides more pyrolysis liquid fuel than inactivated catalyst. Various researchers reported that activated catalysts with low acidity can promote higher pyrolysis liquid fuel. This is due to the increased cracking of hydrocarbon to light hydrocarbon, double chain bleaching, and shortening of the long hydrocarbon in paper pyrolysis. The physical property of liquid fuel, it is seen that the higher heating value of all pyrolysis so still in the range energy contained of the commercial kerosene of about 40 megajoule per kg. Of about 30 megajoule per kg. The pyrolysis liquid fuel resulting pyrolysis with food degradations, both with and without catalyst, still in the density and viscosity in the range of the commercial origin. The QCMS analysis pyrolysis of liquid fuels, the monoatomic component of styrene is present as the mild component in this pyrolysis liquid fuels, mainly consists urine, ethyl benzene, toluene with R in the gasoline hydrocarbon range of C4 to C12. The composition of pyrolysis liquid fuels, all components in the pyrolysis liquid fuel are in the range hydrocarbon of C7 to C16. Commonly, kerosene fuel contain mostly hydrocarbon range of C9 to C16. The overall average hydrocarbon fraction, including aromatics and long hydrocarbon chains in pyrolysis liquid fuel, was obtained at C11.76 to C12.79 is still in the range of kerosene hydrocarbons, which are enriched with the compound of styrene, ethyl benzene, and toluene. So this is the compound will improve the property of pyrolysis liquid fuel as a fuel on a par to kerosene fuel, considering that the compounds are in the range of gasoline range to the carbon of C5 to C12. As the conclusions can be summarized that the use of volcanic ash catalyst has been proven to increase the quality and quantity of pyrolysis of fuel produced from the styrofoam plastic waste pyrolysis. This pyrolysis liquid fuel on a par with commercial kerosene fuel on the strength of physical and combustion properties. The ICENIS spectrum contains hydrocarbon compounds that are similar to standard kerosene fuel, which are enriched with the hydrocarbon elements of the gasoline rank as styrene, ethyl benzene, and fluorine. Pyrolysis liquid fuel can be considered as an alternative fuel to substitute kerosene fuel for the household needs. And also, volcanic ash can be used as a catalyst effectively due to the performance and the wide capability in it. And this is the end of my presentation. Thank you so much for your attention.
Okay, thank you very much for the video of the presentation. Okay. Any question from the audience?
No.
Yes, you have one. You have question? No.
No.
No. If no question, I have one question. For the presenter, you said that you use Mount Krakatau volcanic ash as catalyst. So whether this is only ash from the Krakatau, or we can use the ash from the other mountain, like from the Merapi or the other mountain?
Yes,
Or this? Yes.
Firstly, I should explain. We use the Krakatau volcanic ash because of its height of silica and alumina content compared to other volcanic mountains. Yeah. Besides that, the using of volcanic ash is more cheaper than the commercial catalyst. So there is abundant volcanic ash in our country, and we can use it and we can modify it in order to be used to as pyrolysis catalyst. That's it.
Okay, because this is because of the characteristic of us itself, okay?
Yeah.
Different with the other
Yeah.
guys.
Yeah. Commonly, the catalyst contain silica and aluminum compounds. So from the Krakatau volcanic ash is the higher than the others. Yeah, the highest content of alumina and silica than the other volcanic ash. Can I?
Okay, thank you very much.
You're welcome.
Yes, thank you very much. I think your time is up. Okay, we move to the next. Thank you, Mr. Tono. We move to next presenter. The next presenter is ID paper 1922 with the title Effect of Irradiance and Temperature on Reactive Power Support of Big Grid Based on Constant and Variable Power Factor. Okay, Mr. Saka.
Yeah. Good.
Okay, time is yours. Okay, Mr. Saka, you can start your presentation.
Yeah. All right, ma.
Go forward.
Yeah. Good afternoon, everyone. I think my presentation is seeable now, right? You can see my presentation now.
Yes, I can see your presentation. So you can start your presentation.
All right, yeah. Good afternoon, everyone. My name is Shaka Kabo from Electrical Engineering Department, Diponito University. I'm the presenter and one of the authors for the paper titled Effects of Irradiance and Temperature on Reactive Power Support of Weak Grid based on constant and variable power factor. Yeah. Sorry, I want to adjust this. Yeah, I'm going to talk on the background introduction, which is the introduction, methodology, results, and conclusions. Yeah. Since the development of the solar energy in the 19th centuries, it gains its full momentum implementation from the recent recent decade of years. And it is evident that this source of renewable energy, this source of renewable energy is effective and is implemented everywhere in the country. For the fossil fuel, it is the major source of power generation globally up to this present time. It covers a large percentage of the power generations. However, it has some disadvantages, such as the scarcity of resources. It is evidence that its resources will be diminished in the near future. However, that the implementation of the PV is assured for a great alternative for this conventional energy generation. And next, the CO2 emission is a daily basis. It increases every day. It causes disasters, environmental issues, etc. But due to the rapid implementation of the PV generation, we hope for a clean environment in the near future, as well as the cost of transportation, cost of maintenance, and the cost of generation as a whole is a challenge that we encounter through the conventional method of generation. But for the PV generation, it's what gives a very good assurance of overcoming these challenges. The availability of power is now ensured in different parts of the regions of countries globally due to this implementation of PV generation. In general, the PV generation is simple and environmental friendly means of generating power. However, it has some challenges to the grid. It has a great challenge in addressing challenges such as short circuit, faults, unbalanced voltages, harmonics created by the converters, energizing loads on the grids. All those challenges are very difficult to address due to the lack of reactive power. This led to a lot of researchers focusing on injecting reactive power to the grid. Next, the variable irradiance and temperature is also a threat to the grid due to the fluctuation of power. Now, from this one, the gap of the study is developed by these two research. The first one is focused on extracting the maximum reactive power produced by the PV. The authors are focused on maintaining the grid code conditions, as we can see from this one, the grid code of different countries. So they succeeded in achieving extracting the maximum power from the PV. Yeah, the second research here is focusing on maintaining the voltage flicker on the grid when there is a high penetration of PV during the days, the peak hours, by containing the active power and controlling the reactive power constantly to maintain the flicker, the voltage flicker. However, from these two researches, we developed our research to inject reactive power constantly, as well as injecting reactive power which is not constant in maintaining the grid power factor in order to investigate the effect of irradiance temperature on the inductive load. Now, This one is the topology of the methodology, which it's implemented with a two-stage converter. The first stage is a DC-DC converter that boosts the DC voltage through the use of MPPT that extracts the maximum power of the PV at any given point. This maximum power, which is the active power, is delivered into the grid by a DC link converter, a DC link control, sorry. The reactive power is extracted from the PV through a ramp factor, as we can see, and this power is delivered to the grid through external reactive power control. Now, these powers are synchronized to the grid with the help of a PLL phase lock loop, and this entire system is a weak grid based on the short circuit and reactance resistance ratio determined by the grid impedance. The control system is implemented with a PI controller. The DC link control is generated the D-axis reference current to inject reactive power to the grid through the help of the inverter. And while the external reactive power control is generating the Q-axis reference current to inject reactive power to the grid. As we see, the internal reactive power is internally controlling the active and reactive power that's injected to the grid. Now, this synchronization of this power is done by a DSO and GI based PLL synchronization, in which the frequency and the phase are determined, estimated to convert the ABC signals to DQ signal for synchronization. The results are summarized in this table. Now, the two conditions that we injected the reactive power is this. The first one is we maintain the power are variable to their maximum point, as we can see here, because they vary. However, the results that we obtain at this point is very appreciable. All the voltage for steady stage, startup and loading are very good, as we can see. However, the variable temperature at this case is given a more appreciable voltage compared to the irradiance, variable irradiance. The next case that we simulated, we maintain the power and the reactive power constant in this case, so its maximum value that we need. Now, at this point, the active power varies, the power factor varies too. The voltage that we obtain in the grid is this. So we can see that the voltage is also improved. But however, the voltage for the variable irradiance at this point is a little bit higher than the voltage of irradiance at the first case. But all the voltages are very appreciable. Now, the active and reactive power we injected is shown in this graph. The first graph here is the irradiance and temperatures that we injected, that the constant for the constant condition and the variable condition, I suppose, that we got from the grid. The third graph here is the active power and the fourth graph, the active power. We can see that when we maintain the power factor constant, as we can see, we derive the maximum reactive power from the grid, as we can see from this graph indication with the yellow column. And the next stage, the next case, we try to maintain the reactive power constant. In this case, the power factor varies as the active power varies, as we can see from this two graphs. However, the variation of power is minimal for temperature, as we can see. When the temperature is raised, the voltage drop is very minimal. Yeah, this is the response of the power for the inductive load. that the active power is showing at this point is indicating that the effect of irradiance and temperature has nothing to do with the active power of inductive load. Therefore, the reactive power of the inductive load, we can see at this point, is affected. For constant reactive power and variable reactive power to be injected, all indicating here a variable reactive power absorbed by the inductive load, irrespective of the constant reactive power we injected. Yeah. In conclusion, we can see on both cases in which we injected reactive power and constant and variable, and the voltage is improved on both cases. Second, and the other point of the conclusion, when the irradiance are low, the inductively from the PV and from the PV inverter is not producing a constant reactive power absorbed by the inductive load. The inductive load reactive power that we injected from the PV. And then we find out that the fluctuation of the voltage is significant in variable irradiance, which led to a fluctuating of reactive power as well. However, there is a very significant even negligible if the variable temperature that we get from the results. Yeah, thank you. I ended my presentation at this point. Thank you everyone for giving me an audience.
Okay, thank you very much for your presentation. Any question from the audience?
No.
Your presentation from Indonesia, or is still in your country?
No, I'm presenting from Undip.
Oh, from Undip. So you stay in Indonesia?
Yes, ma'am. I'm staying in Indonesia.
So what's you are from what country? Hello, I think you are international student.
Yeah, I'm an international student. I'm a student in the electrical department, the Bonigro.
Okay, so
but
what
actually
country
I finished my study. Yeah, I'm coming from Sierra Leone, West Africa. Yeah, but actually I finished my studies. Yeah, this.
Okay, so you have finished your study. Okay, good.
Of course.
Okay, any question from? Okay, any question from the audience? So if there's no question, I have one question for you. So what is the novelty of your research? I mean, what is something new in your research? What is different with the other research that conducted something maybe similar with you, but you have something new to declare? You can explain to us.
Yeah, the something that's new in my research is the other research that we found. They investigated the effect of irradiance and temperature on the power injected to the grid. But however, there is no research that's clearly investigated the effect of this irradiance and temperature on the reactive power absorbed by the inductive load. So for this one, we are trying to compare the effect of irradiance and temperature on the inductive load, due to the reactive power injections. So in this case, we injected two sets of reactive power to see how it affects, how it can be overcome the effect of irradiance and temperature. That's why we injected a variable reactive power and a constant reactive power. However, we found out that the effect of irradiance and temperature, the effect of irradiance overcome the reactive power we injected. That means in the expectation, we expected the reactive power when it's injected constantly, we expected that it can overcome the effect. In this case, we expected the inductive load to get a smooth reactive power absorption compared to when it's injected, based on the power factor maintenance. So, however, the result is showing that for both cases, the reactive power absorbed by the load is the same due to the effect of the irradiance.
So so you conduct like some simulation, okay? Okay, thank you very much.
Yes.
I should call you Saka.
Yeah.
Thank you very much, Mr. Saka.
Yes,
see you again. Okay, thank you.
Yeah, thank you
your
very
time
much.
is up.
Yeah, thank you very much.
Okay.
Yeah, thank you very much.
Okay, now yes, thank you. Now we move to the next one. The next one is paper ID 1938. 1938. Mr.
Present.
Maulidia. Okay.
Yes.
With the title synthesis of TO2. What is we call TO2? MgO catalyst via a salt gel method for biodiesel production from palm oil mill effluents or POME. Okay, so you can start your presentation.
Yes.
Yes, time is yours.
Okay.
Okay.
Can you see my slide?
I cannot see your slide. You can try again. Okay, still in process.
Okay.
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 Yes, you can start now.
Yes. Okay. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
First of all, I would like to say thanks for the opportunity. Today, I will present our result about synthesis of titanium dioxide doped magnesium oxide catalyst via a salt gel method for biodiesel production from palm oil mill effluent, POME. As introduction, nowadays, global consumption of fossil fuel such as natural gas, petroleum, and coal has increased, resulting in serious environmental problem. This problem was due to increased population, transportation, industry sector, household, and agriculture. Biodiesel was reported as a promising alternative fuel source due to its environmentally friendly nature and potential to be developed. Besides that, the fuel does not harm the environment because it has fewer gas emission. In recent years, studies the production of biodiesel from waste oil into the most desirable hot topic and renewable fuel. Currently, the main obstacle in biodiesel production is the selection of feedstock and adequate and abundant. Utilization of feedstock such as foam for biodiesel production into an intensive study in recent years. Besides, the foam selection in biodiesel production can reduce environmental pollution, reduce waste disposal costs, and energy efficiency. Until now, the choice of catalyst is still a major problem in biodiesel production. Compared with homogeneous catalyst, heterogeneous catalyst more desirable because it has many advantages, including catalyst separation process is relatively easy. The catalyst can be regenerated, economical, and reusable. Therefore, the study was focused on finding suitable heterogeneous catalysts and giving good results. In addition, titanium dioxide was reported as the heterogeneous catalyst or most in demand because of its excellent photocatalytic in the translocation process, environmental friendly and non-toxic. In addition, T2 are most demand because it is wide application in various fields such as antibacterial, antifungal, gas sensor, solar cell, photocatalytic, cosmetic, and water treatment. In this research, we combine titanium dioxide and magnesium oxide for two heterogeneous catalysts to produce a biodiesel. Okay, research method. First, preparation of foam. After that, esterification reaction and trans-esterification. And then synthesis of titanium dioxide dapat magnesium oxide catalyst. And then we using GCMS for analyze the component of biodiesel. And the last properties of biodiesel. Okay, result and discussion. GCMS analyzed the composition of methyl ester of biodiesel produced from foam was analyzed by GCMS spectrophotometry. This analysis result in specific peak for each component. The methyl ester component that was detected can be seen in figure 1, where so that methyl hexadecanoic acid, methyl 8.11 octadecadionate, methyl 7 octadecadionate, methyl octadecadionate, methyl 10 hydroxyhexadecanoic, 2-ethyl aspirin 1,1,1,3,5,5,5 pentamethyl 3-siloxane. Okay, next. The foam biodiesel was further test for physical chemical properties and compared with the ASTM 6751 specification. The properties test including viscosity, density, saponification value, AOD number, and certain number. The graph in figure 2 show the viscosity of formed biodiesel is within the range of ASTM 6751 specification. It was observed that the viscosity decreased in the ratio of titanium dioxide doped magnesium oxide 1:1, catalyst of 2.55 millimeter per second, cause the long reaction time and increase of temperature. And then, therefore, it is so that the addition of catalyst affect the density of biodiesel. The greater the amount of catalyst used, the greater density of the biodiesel product. The highest density was produced at the ratio titanium dioxide doped magnesium oxide catalyst to 1:1 of 852 kilogram per meter, and the lowest density result from titanium dioxide doped magnesium oxide catalyst 0:1 without the addition of titanium dioxide of 853 kilogram per meter. Then the iodine number in this study are also already fulfilled to the specification of the ASTM 6751 standard can be seen in figure 2C. The graph in figure 2C so the formed biodiesel obtained from the ratio of titanium dioxide doped magnesium oxide catalyst 1:0 has a lower iodine number of 12.57 gram iodine per gram than from other ratio of catalyst. And then figure 2D, it was observed that the saponification value increased with the addition of titanium dioxide in the titanium dioxide doped magnesium oxide catalyst. It showed that the role of titanium dioxide in excellent catalyst during the process of transesterification. The saponification value of biodiesel obtained in this mode within the range of 234.03 gram potassium hydroxide per gram to 262.07 gram potassium oxide per gram, with an average value of 244.63 gram potassium hydroxide per gram.
One minute more. 1 minute more. Okay, please be quick.
Okay.
Yes.
And certain number, so that the highest certain number of the formed biodiesel is the ratio of titanium dioxide doped magnesium oxide catalyst 1.0 of 60.79. And conclusion, the first titanium dioxide doped magnesium oxide catalyst was prepared via the Sesion method, the greatest biodiesel yield was obtained under optimal condition, or 30.84% at erection time of 3 hours and temperature of 15 degrees with the ratio of titanium dioxide dapat magnesium oxide catalyst 1:3. GCMS analysis saw that 7 fatty acid were confined, such as methyl ester, confined were methyl hexadecanoic, hexadecanoic acid, methyl octadecanoic, methyl octadecanoic, methyl octadecanoic, methyl hexadecanoic, and heptamethyl trisiloxane. And last, all properties of biodiesel such as viscosity, density, saponification value, unit number, and certain number in the study with the ASTM 6751 standard. Okay, I think enough. Thank you very much for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you. Thank you very much for your presentation. Any question? Synthesis of titanium and magnesium catalyst via salt gel method for biodiesel production from palm oil mill effluent. Okay. Any question? Okay. So, Mr. Maulidia, this is a new catalyst. You said synthesis of titanium and magnesium catalyst. Any catalyst besides titanium and magnesium can be used? Or we should use this catalyst to production biodiesel production, or maybe we have another catalyst. So what is advantage we can have with this titanium and magnesium catalyst?
Okay, please, can you repeat your question? I don't hear because in this mail question, raining hard. Please, can you repeat your question?
Yes, you use titanium and magnesium as catalyst.
Yes,
for this research. I wonder there are another catalyst we can use. Okay, another catalyst we can use, not titanium and magnesium. Maybe, yes. I don't know. Yes. Okay. So if there are another catalyst, why you use titanium and magnesium as catalyst? Any advantage we can have with the use of titanium and magnesium?
Okay. Okay. Thank you for your question. I will try to answer your question. Why I use the titanium dioxide doped magnesium oxide for
Yes.
biodiesel production?
Yes.
Biodiesel production.
Maybe we have the other catalyst with besides
Yes,
titanium and magnesium. Yes.
Yes, because titanium dioxide have many advantages, such as titanium dioxide have properties such as a large surface area, and then wide band gap. Besides that, chemical stable and low cost. So in this research, we choose titanium dioxide doped magnesium dioxide because we see we look the from properties of from material titanium dioxide doped magnesium dioxide, including such as surface area of titanium dioxide to to use
No.
process transamplification process the formed by the cell, and then titanium dioxide have low cost and stable stable when used as a catalyst for biodiesel production.
Okay. So this is about, so yes, maybe I can little bit understand what you're talking about. Okay, so this is main advantage with use the titanium
Yes,
and
yes.
magnesium as catalyst. Okay. So thank you very much for your time.
Yes, thank you very much.
I don't know, maybe you are the last presenter or we have the other presenter. Okay, thank you very much. The number is, the next presenter is 1982.
Excuse me, Prof.
Yes.
Mr. Agus Rudiono and the team, they are not here today. They canceled the presentation.
Oh, cancel the presentation. Okay, so this is the end of this session. You want to take a picture of us?
Yeah.
Okay, so
maybe for the all participants, if you want to join take a picture, maybe you can turn on the camera, please.
Okay, please turn on your camera, Mr. Maulidia. I think your camera still.
Yeah, it's okay. 1, 2, Mr. Maulidia, are you ready?
Okay.
1,
Yes.
2, 3. Once more. 1, 2, 3. And the last information for the all participants, please don't forget to join for the closing ceremonial maybe and 5 PM waktu Indonesia Barat. Don't forget to join the closing ceremonial. I get information for the committee. Thank you for the all special for
Zoom password, excuse me.
Yeah.
Zoom password for the
Same the password in
memory.
Yes.
Okay, thank you.
Yeah. Thank you for the all participants, especially for the Prof. Ari Susanti. Thank you. Thank you for the all. Thank you.
Okay, thank you very much. Okay.
Yeah, thank you. Thank you.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
See you again.
Thank you.